Okay, so we're going to talk about section 2.2, and I am putting a timer on my phone right now. So this section has 7 objectives. So we're going to get through as many objectives as we can in 20 minutes, and then we're going to finish in class tomorrow because the video shouldn't be that long, hoping we can get through 4. Okay, so section 2.2, it's easy. There's just a lot of information in it. It's about organizing quantitative data and the popular displays. So again, our 7 objectives overall. The first thing that we're going to do is organize discrete data in tables. We're going to construct histograms of discrete data. We're going to organize continuous data in tables. We're going to construct histograms of continuous data, and hopefully, again, we can get up to that in our 20 minutes. Then we're going to draw stem and leaf plots. We're going to draw dot plots. And we're going to identify the shape of a distribution. So pretty much the first 6 you should have seen in algebra, depending on what year you took that. It might have been last year, the year before. Definitely should have seen all of that in algebra. Again, we'll take it a little bit further, and number 7 is definitely going to be slightly new to you. Okay, so the first step in summarizing quantitative data is to determine whether the data are discrete or continuous. If the data are discrete and there are relatively few values of the variable, the categories of data classes will be observations, as in qualitative data. If the data are discrete but there are many different values of the variable, or if the data are continuous, the categories of data, the classes, must be created using intervals of numbers. So again, discrete, 1, 2, 3, 4, 5, 6. Okay, if it's continuous, it can be 1, 1.2, 1.3, 1.4, 1.34, so on and so forth. Okay, so objective number 1, organize discrete data in tables. So again, 1, 2, 3, 4, 5, 6, something that's countable. Okay, so the following data represent the number of available cars in a household based on a random sample of 50 households. Construct a frequency and relative frequency distribution. So we sort of did this in the last section, but the only thing is that the table isn't built for you already. So again, when I look at my data, I'm going to look for my lowest data value, and my lowest data value is 0, and my highest data value in here is 5. So we're going to go from 0 to 5. Okay, and you can see that we have our number of cars, the 0 to 5, like I just said. And again, there is no in between. You can't have 1.2, you can't have 1.3. So 0, 1, 2, 3, 4, 5. So now we're going to go through, and again, we're just going to make a tally of how many cars are in each one. And again, if this is my problem, as I'm doing my tally and I'm going back, I'm going to cross it out. So in 0, there'll end up being 1, 2, 3, 4. Okay, and then number for how many cars have one household, it's going to go up to 13. Remember, I like to do the cross out to signify my groups of 10. Okay, and then so on and so forth. So again, there's answers on the next slide. It looks better than me handwriting it, but again, just because I'll talk about it on this slide since I have these 2 already. So the frequency for 0 is going to be 4. The frequency for 1 is going to be 13. And again, how are you going to get your relative frequency? You're going to end up adding straight down your frequency column and then dividing by the number that there are. Again, the numbers are on the next slide, but it's going to be 50. So when you get your relative frequency here, it's going to be 4 divided by 50, which is going to be 0.08. So let me bring up the next slide that has all the answers on it for you. Okay, so again, how many households have 0 cars? There's 4. How many households have 1 car? 13. 2 cars, there's 22 households. 3 cars, 7 households. 4 cars, 3 households. And 1 household has 5 cars. So again, if you add straight down this column, you should get 50. Okay, so to get your relative frequency, remember you're taking your frequency from this column and dividing it by the total frequency, which is 50. So 4 divided by 50 is going to give you 0.08. 13 divided by 50 is 0.26. 22 divided by 50 will give you that 0.44. 7 divided by 50 gives you the 0.14. 3 divided by 50 gives you the 0.06. And 1 divided by 50 will give you the 0.02. Okay, and it's as easy as that. We're already on to objective number 2. Okay, so objective number 2 is going to be to construct histograms of discrete data. Okay, now, A histogram is constructed by drawing rectangles for each class of data. So this is directly related to the bar graphs that you did yesterday. The only difference is with a histogram, your bars must touch. And although I didn't even show you an example, because again, I'm a creature of habit, I didn't show you an example of this. The bar graph can either be horizontal or vertical. A histogram has to be horizontal. And your frequency is always going to go up your Y side. It's not an option with a histogram. A bar graph it is. Okay. So again, we want to draw a frequency and a relative frequency for the number of cars per household data. So this is the data that we just found. So the first one that we'll do is our frequency histogram. Okay, and again, I would just do a little pre-planning. You have 5 cars in total. And again, this side must be frequency. Okay, in a histogram, it is not an option. Y must be the frequency. Okay, so you had your highest frequency was a total of 22. So I have to go up to 22. You can go a little higher than 22. So I think if I try to do 5, 10, 15, 20, 25, let's see if we do 5, 10, 15, 20, 25. So that's what I would do. I would make every other bar worth 5. So I would make 5, 10, 15, 20, and 25. Okay, and then across the bottom is going to be your number of cars. Okay, and we had 0, 1, 2, 3, 4, and 5. So I have to have 5 bars all together. So I think I have enough room again to make every bar worth 2. Yep, 2 long. Okay, and I'm just going to do the first bar, and then I have a completed chart on the next slide. Okay, so for one car, you had 13 people that had, I forgot 0. I can't do, you can't do, and now I can't erase. I forgot 0 cars. So you're going to have to end up making it worth 1. I apologize. So you're going to have 0, 1, that'll be 2. I can't change the color of my pen either. 3, 4, and 5. Okay, so let's do the 0 cars. So for 0 cars, you had 4. That's going to be a little less than 5. And again, there you go. I'm going to draw one more again. 13. Okay, 13 is somewhere between 10 and 15. And again, the difference here between what we were doing now and before is notice that those bars touch. Okay, so there is what your histogram should look like in the end. Again, take a second, make sure that you draw yours and make sure all your bars are touching again. Okay, and then we're going to do the same thing for our relative frequency histogram. And we are going to do our relative frequency histogram. And again, that's based on the other column of your table. And again, just a little bit of pre-planning here. If I look at my relative frequency, again, think of relative frequency as money. So cents. So your biggest cents was 25 cents. Okay, and your bottom is still going to be the same. We're still going to go from 0 to 5, but we have to go up to 25 cents. So again, a little bit of pre-planning. Let's see what happens. If I do, let's see if I do by 5 cents every other. Yep, that'll work. Okay, so I'm going to go every other bar is worth 5 cents. It actually has to go up to 26 cents, but we'll deal with the one as it is here. Okay, and we're going to go 0, 1, 2, just to space it out a little bit more, 3, 4, and 5. Okay, so for 0, you had 0.08. Okay, that's going to be a little bit more than 5 cents, but less than 10 cents. So that'll be your first bar. And again, just make sure your bars touch. And again, this side has to be your frequency with a histogram. It is not an option. Bar graph, it's an option. Here, it's not. Okay, and then for 1, we're going to go up to 26 cents, which again, is just going to go a little bit higher here. Okay, and bars touch. So again, just make sure that you complete that histogram. And when you do, that should be your relative frequency there. Okay, they counted by 10 cents there. I counted by 5 cents on the other side. It's up to you. It doesn't matter which way that you do it. Okay, you're the author of the graph, so no big deal. Okay, objective 3, we're going to organize continuous data in tables. Okay, so again, continuous data can be data that you have now, stuff that's in between. So instead of 0, 1, and 2, you can have 0, 0.1, 0.2, 0.23, things of that nature. Okay, so classes are categories into which data are grouped. When a data set consists of a large number of different discrete data values, or when a data set consists of continuous data, you're going to create something called classes. And what you're going to do for that is you're going to use intervals of numbers to represent your data. Okay. So the following data represents the number of people aged 25 to 64 who are currently work disabled. So again, you can see your ages there. From 25 to 34-year-olds, you're going to have 2,132. For 35 to 40, 3,928. 45 to 54, 4,532, and from 55 to 64, you're going to have 5,180. Okay, so we're going to talk about something called class limits here. Okay, so the lower class limit of the class is the smallest value within the class, while the upper class limit is the largest value within the class. Okay, the lower class limit of the first class. So this is the top thing is the first class. And then again, you just move down. This would be the second, this would be the third, and this would be the fourth. So you have 4 classes here. So the lower class limit of your first class is 25. Okay, the lower limit of your second class is 35. The lower limit of your third class would be 45, so on and so forth. Okay, the upper limit of your first class, upper is going to be 34. Your upper of your second class is 44. So it's lower on this side and upper on this side. Okay, and here's the most important thing on this slide. We're going to talk about something called the class width. Okay, the class width is the difference between consecutive lower class limits. It's not a lower and an upper, it's 2 lower limits. And difference means subtract. Okay, so lower, this side. Okay, and it has to be consecutive. Doesn't matter which consecutive that you use, but it has to be consecutive. So if I look at the ones that I have highlighted here, I have a 25 and a 35. So the difference between 35 and 25 is 10. Okay, class width has to be positive. So again, when I look at the 25 and the 35, notice I put the 35 first and then the 25. So it's always the higher value minus the lower value. Again, class width cannot be negative. Okay, so the following data represents the time between eruptions in seconds for a random sample of 45 eruptions at Old Faith Geyser in Wyoming. And we want to construct a frequency and a relative frequency distribution of the data. Okay, so here's my data. And again, as you look at that, we're going to have to do some pre-planning here. So again, I know it's hard because I'm switching slides, but you have the data in front of you. Okay, and when I look through that data, the smallest data value that you see there is 672, and the largest data value should be 738. So when I'm planning my classes, it has to be inclusive of that 672, but every class width is going to end up having to be the same. So the first thing that I'm going to do is I would probably start with a lower class limit of 670. Because that will then include my 672. And then I'm going to do class width of 10. So we're going to include 10 numbers in each class. And what that will end up looking like, here you go. You'll go from 670 to 679. Again, 679 is already here. So your next one has to start at 680. Again, there are 10 numbers here. Again, class width. You're subtracting 2 lower limits. So 680 minus 670 gives you that 10. And then you're just going to keep going up. And again, you'll finally get up to your 739, which is going to be inclusive of that 738. Okay, so then I'm going to put those classes into a table. And again, you're going to start to do your tallies again. So again, you're going to go back and look back at that table. I am going to do this by hand because on the next slide, I do not have this one typed out. So if you go back and look at your eruptions, again, I would do them. I have the answers in front of me, so I'm just going to copy down my table. But again, as you're doing it, cross out the number, put a tally where it belongs. Cross out the number, put a tally where it belongs. Okay, so you're going to have 2, 2, 0, 0, 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 1, 2, 3, 4, 9. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1. This one has 11. 7, nope, that one has 9. I lied. I can't erase. 1, 2, 3, 4, 5, 1, 2, 3, 4. That one has 9 also. The next one has 11. 1, 2, 3, 4, 5, 1, 11. And 1, 2, 3, 4, 5, 1, 2, 7. Okay, and then again, to find your relative frequency, again, you are adding up your total frequencies here. When you do that, you should get an answer of 45. And that means for your top one here, you're going to do 2 divided by 45, which will give you 0.044. Then this one's going to be 0 divided by 45, which will be 0. That's an obvious one. 7 divided by 45, 0.1556. I'll stop writing the divide part. I'm just going to write your answers. 0.2, 0.2, 0.2444, 0.1556. So there is a frequency table for grouped data or continuous data. So the choices of the lower class limit of the first class and the class width are relatively arbitrary. Again, you're the author. You just need to make sure that all your data is included in the table. Okay? There is no one correct frequency distribution for a set of data. Okay? However, some frequency distributions can better illustrate patterns within the data more than others. So constructing frequency distributions is somewhat of an art form. So again, on that last one, I only had the 670 on the bottom was 2 away from my smallest number. The 639 as my upper class limit for that last class was only 1 away from my top piece of data. Okay, so that kind of included everything. Could I have made it better? Maybe if I made a class width of 5, maybe I would see more of a pattern inside of it. So again, it's kind of up to you because you're the author of that chart. And it also depends on what you're trying to get that chart to say. Again, you can make statistics say whatever you want. Okay, so use the distribution that seems to provide the best overall summary of the data. So depending on how true you want that distribution to be, it's going to depend on the class widths that you're going to use. Okay, so if I change those class widths, like I was just saying, to 5, then this is the information that I would get. Okay, and notice if you go back to your last table, I only had 1 class that had 0 in it, and now notice here I have 3. So it kind of spreads out your data a little bit more, might give you more helpful information. Again, it depends on kind of what you're looking for, but this would be what the table would look like if you went by 5s. Okay, it looks a lot different than the one that you just had. Okay, so guidelines for determining the lower class limit of the first class. Choosing the lower class limit of the first class. Choose the smallest observation in the data set or a convenient number slightly lower than the smallest observation in the data set. So again, we had 638 was our smallest data value. No, that was 738 was the highest one. Our smallest data value was 672. 672 was the smallest data value. So again, I chose a number a little bit smaller than that, so I went down to 670. Again, makes it convenient, okay, and easy to count when you have usually by 5s or 10s, sometimes 2 as well. But if you have a large set of data, you don't want to be counting by 2s. Okay, so again, guidelines here: determine the class width by computing the class width. I don't know why my equal signs aren't coming out here. Your largest data value minus your smallest data value divided by your number of classes. So for objective 4, we're going to construct histograms of continuous data. So we're going to take that chart that we just made before, the one that we did, not the one that I showed you after, the one that went by class width of 10, and we're going to make a frequency histogram for that. Okay, so constructing a frequency histogram, again, using the class width of 10. So the one that was on the last slide. So again, you're just gonna have to do a little bit of pre-planning. And again, this is frequency, not relative frequency. So your highest frequency on that last one was 11. So I need to be able to make sure that, and that's my timer. Okay, so let's do this example and then we will stop. Okay, so I want to make sure that I can go up to 11. By looks of it, I think I'm going to have to make every line worth 1. So I'm just going to write every other so it's not so messy. And there we go. Okay, and then across the bottom is going to be your interval. Now here's the thing. My first number starts at 670. So what you have to do with a histogram, since your intervals don't start at 0, you have to put a heartbeat in there, or you can just leave a space. But you can't have your bar start at that vertex point because that would imply that it started at 0. Okay, and I think probably you're going to have room to make each bar worth 2. So this first bar here is going to represent 670 to 679. My second bar is going to represent 680 to 689. Then 690 to 699, 700 to 709, 710 to 719, 720 to 729, and 730 to 739. Okay, and for 670 to 679, you have 2, so you're going to go up to 2. And again, draw your bar. And again, with the histogram, you just have to make sure that your bar is touched. Now, here's going to be the only difference. From 680 to 689, you have 0. So that I am going to leave blank. But now I'm going to start my 690 to 699. I had 7. So we'll go up to 7 there, over and down. And again, I'm just going to do one more bar. I have a completed chart on the next one. So your next bar is going to go up to 9. And again, there. So for a histogram, the only time that you will ever not have your bars touch is an example like right here where you have 0 as a data value. Again, complete that histogram. And this is what it should look like in the end. Again, you can put this information into Excel and Excel will make that table for you. And that's how I got the slide that you are currently looking at. Okay, so tomorrow when you come in, we're going to go on to the next slide, which is going to be the relative frequency histogram for this. And we'll do that live. And then we'll talk about the rest of the stem and leaf plots and all that sort of stuff and the dot plots during class.